All right, so the last time we talked about energy, we were talking about potential energy and kinetic energy. So remember that kinetic energy is the energy of motion, and potential energy, what we're going to be talking about is gravitational potential energy, and that's the energy that is stored in an object because of its position relative to the ground. So remember that the formulas, we can write those down real quick, that the formulas for potential energy was mass times gravity times height. And I can write that over here. Okay, and sometimes we had a G out front for gravitational potential energy. Sometimes you might also see it written as this with a little g, but it's the same thing. And that our kinetic energy, our formula for that was 1/2 times mass times the velocity squared. Okay, and remember that our unit for energy is joules with a J, capital J. Okay, so what we're going to be adding to that now is the total energy that's involved. The total energy is going to be the sum of our potential and kinetic energy, and that just means that we're adding them together. So potential energy plus kinetic energy is going to be equal to your total energy. And the total energy that we're talking about is the mechanical energy. So sometimes you'll see that written as ME or E total. Sometimes you might even see total mechanical energy, TME. Those are all just different ways of saying the total energy of the system, of whatever we're talking about. So we have the law of conservation of energy, and that says that our energy cannot be created or destroyed, but it can change forms. It can be transformed into different kinds of energy. So energy continually changes form, but it does not just appear, and it never just disappears. The law of conservation of energy states that energy cannot be created or destroyed, but it can change form. So, for example, you can transform your energy from kinetic into potential and then back to kinetic. That's one way of transforming energy, and that's the most common kind of transformation that we're going to talk about. There are other transformations as well, but we're going to be talking about kinetic going into potential, going back to kinetic, going back to potential, back and forth like that. Okay, so the energy of a pendulum, and hopefully you guys saw this in the gizmo that we did, but as the pendulum swings back and forth, our kinetic and our potential are transforming into each other. They're changing. As one goes up, the other goes down, and vice versa. So as the pendulum swings, the energy changes from potential to kinetic and back, but the total energy, that's really important, guys, the total energy of the system is going to stay the same the whole time. Okay, at point A, if we look over here, point A is over on the left side, or sorry, over on the right side. A little bit different than what we're using, but point A is over here. That's the highest point of the pendulum that it reaches. Okay, so we are going to consider that its highest point, and that's going to be where all of our energy is potential energy. Okay, so at this point A, our KE is 0, and our PE, our potential energy, is max. Whatever that is. It's the maximum. At point D, you can see that down here. That's the lowest point. That's at the point where the pendulum is going to be moving the fastest. And so that is where the kinetic energy is the maximum. And because it's the lowest point now, our potential energy is 0. And so, as you can see, at point A, we had a lot of potential energy, and then as we move to point D, our kinetic energy is increasing and our potential energy decreases. Okay, That's really important. They're changing, they're transforming into each other. Okay, and then you have your total energy is going to always stay the same. And notice that the maximum here, whatever this number is going to be the same number that number was. So the potential energy at point A is going to be equal to the kinetic energy at point D. Those two numbers should be the same because the total energy is the same always. So that's why those two numbers should always be the same. If we look at a roller coaster, for example, we're going to introduce energy bar charts here. So looking at a roller coaster, imagine you're at the top of the first hill. So we're right here. It's just like the pendulum when we were at our highest point. We have maximum potential energy and zero kinetic energy. So that's why if you look here, our potential energy is all the way to the top. And our kinetic energy is all the way at the bottom. Okay, then we go down the hill. As we travel down the hill, okay, our potential energy is starting to go down a little bit. Okay, where is that energy going? It's transforming into the kinetic energy, which is now going up. So it was at zero, and now it's increasing because as we go down the hill, we start to increase our speed. And remember that speed and velocity are kind of the same thing, but velocity includes direction. So as we are increasing our velocity, that means our kinetic energy is going up. Okay, and then as we get to the bottom of the hill, you can see that our potential energy is down and our kinetic energy is now at its maximum point. It's increased all the way up. So that's the bar chart kind of representation there. And you can just see that it just shows you kind of the transformation. So they continually change back and forth throughout the whole ride. You're never going to lose any energy. Your total should always stay the same. So like I said, during the entire roller coaster ride, energy is conserved. No energy was ever created or destroyed. It was only transformed. The potential and the kinetic were going back and forth. So this would be like in an ideal situation where we would not have any kind of loss of energy. But sometimes it does appear that we might lose energy. And we might lose mechanical energy. It could be transformed into another kind of energy if there is friction. Friction. So sometimes it seems like we do lose energy even though we know that isn't true, and because of friction. Friction causes energy to be turned into heat and maybe sometimes other forms. So heat would be like thermal energy, which is different from the mechanical energy we were talking about. So energy is still conserved, it's just changing form. So heat is thermal energy. Other forms, we have sound, we have light, we've got chemical energy. There are all kinds of energy out there. But the most important one we're going to talk about is the mechanical energy, where we can see the transformation of potential and kinetic energy. And most of the time, we will talk about being frictionless, where there is no friction. But when there is friction, we don't lose energy, but we lose mechanical energy. It transforms into heat or thermal energy. So it's being conserved still, but it's changing form, and that's okay.